Hi, and welcome to Math 112. This term we are going to continue our adventures with functions that you began in your previous math class. Let me give you my screen and we will begin. We'll get going. My name is Anne-Marie Harden and I am your instructor for this course, as you know by now. This is a challenging course. If you have any questions, please reach out and contact me. I am here to help you. You can find me on the Pendleton campus, and all of my contact information, remember, is on the course website. So let's do this. Okay. I am going to use PowerPoint demonstration slides. When we get to examples, I encourage you to try to work through them, at least think about how you would approach this before I show you the solution, and I'll pause and give you a chance to do that. Remember that you can always pause these videos and back them up if you miss something, or pause them and work through an example before you take a look at the solution so that you can check your own understanding. So we're going to start by talking about circles. There we go. So we all think we know what a circle is, but I would almost wager to bet that you've never actually thought about the mathematical definition of a circle. So here we go. The circle, a circle, is the collection of all points that are the same distance from some point that we choose. That point that we choose is called the center. And in general, we will denote that center point with the coordinates HK. That's a mathematical convention. Whenever you see the point HK somewhere, you want to think, hey, that point is probably important. For a circle, that point, that coordinate h, k, denotes the location of the center of the circle. Now that distance that I talked about a minute ago, that's just the radius of the circle. So the collection of all points that are a given distance r from the point HK will form a circle in the Cartesian coordinate plane that is centered at that point HK. So we're going to develop the standard form of the equation for a circle, and this equation will form the basis of a lot of our work this term. I know this course is called trigonometry, and you may be wondering what the heck we're doing talking about circles. But trigonometry is really our nickname for this course. This course really is elementary functions. And so we're going to talk about a lot of different functions. We're going to spend a lot of time with the trigonometric functions, but the trigonometric functions are really based on what happens around a specific circle in space. So we're going to start by understanding circles. In order to understand circles, we have to understand the distance formula. And you may or may not recall this from previous classes. So I'm going to give you the formula for the distance between 2 points in space. This distance formula is one that you want to become familiar with, and you want to memorize it, and you want to be able to use it. And we will have problems assigned that will help you to become familiar with using it. And I want to caution you that the homework assignments online are pretty short. They may or may not be sufficient to fully cement your understanding in this material. If you find yourself struggling with a given chapter, and you've done the homework, but you're still just not sure what's going on, or you got everything right, but you're not sure why or how, There are extra problems in the book, in the textbook, and there are answers, and I will make sure that you have access to the answers for the questions in the textbook so that you can use those problems as extra practice problems so that you can make sure that you really do understand this material. This class it's a step up, it's a challenge. We're going to ask you to do some mathematical thinking at a level you might not have done before, but it's a skill that can be developed. So put in the work, reach out, ask me questions, and we'll get through this. As long as you work hard, I will answer your questions. Actually, I'll answer your questions even if you're stuck and just floundering. So don't ever be afraid to ask me questions, okay? But this is the distance formula, and here's what it says. It says that the distance between any 2 points in space, and this is going to be the shortest distance possible between those 2 points, which is also always going to be the distance along a straight line that connects them. The shortest distance between those 2 points can be found essentially from the Pythagorean theorem. I'm not going to derive this formula for you. There is a derivation in your textbook if you're interested, but what we do is we look at the coordinates of the points, and we take the difference between the x coordinates and we square that. Then we take the difference between the y coordinates, we square that, add them together, and then take the square root. So for the graph I have up here, this point is at the coordinates -3, 2, and 2. And the other point, the other point is at the coordinates 2, 5. We want to find the distance between these 2 points. So we take the difference between the x's, 2 minus -3, and we square that to get 5. 5 squared is 25, plus 5 minus 2, that's the difference in the y's, is 3. Square that. We get 25 plus 9 is 34, and we are going to leave that as the square root of 34. In this course, for the most part, we're going to be interested in exact answers, and we are not going to make decimal approximations. So you're going to want to brush off your skills with simplifying radicals, because we're going to do a lot of that. And we are going to leave those as exact answers. We are not usually going to put them in decimal form. Only for solving real-world distance applications will we put things into decimal approximations. And in that case, the online homework will ask you to round your answer to a certain number of decimal points. So those instructions are usually in teeny tiny little text right below the answer box. Be sure and read that teeny tiny little text. Okay, so we're getting there. This gives us the distance between any 2 points. Now think back to our definition of a circle. Definition of a circle is the point for which, or is the set of points, the collection of points, that all have the same distance from some center point. So if we were to put our center point right here, this -3, 2 would not move. And what we would be saying is, okay, well, suppose I want to draw this circle with center point -3, 2, and goes through this point. And I want my computer to do that. Well, so I need to tell it that the radius of that circle is this distance, that's square root of 34. And then tell my computer to draw all of the points that were that distance away from this center point. Here's what that would look like. It looks like this. So we set our distance to be r, and we specify one of our points, our x1, to be at the coordinates h, K. This is just the distance formula with my distance d set at r and 1 point fixed at a specific spot. It's an arbitrary specific spot right now, but it's a special specific spot. Now, to make this equation easier to work with, we generally square both sides and write it in this form right here. We write it as r squared equals x minus h quantity squared plus y minus k quantity squared. Let's play with this for a little bit. If you're not familiar with Desmos, it is one of my favorite graphing tools. And the link is available on the course website. Sorry, I'm trying to get my mouse back. I turned my mouse into a laser pointer, and now it won't click. There we go. Okay. Oops. You're not going to get that screen. Let me fix that for you. There we go. All right. So I'm going to move my circle for a minute. Okay, what I've got up here, this is a circle at radius. Whoa. Sorry, this is a circle, and you can see this because I've got an equation right here that says that r squared equals x minus h squared plus y minus k squared. This is, over here, the equation of a circle. And one of the things I can do in Desmos is I can move stuff around, so we'll play with that in a minute. But, so right now I've got a circle centered at the origin, the point 0, 0, with radius 4, because that's what I told Desmos I wanted to do. So let's change my radius. Let's make my radius 10. What's going to happen? Well, that's exactly what you would expect. My circle gets bigger. What if I make my radius 1? My circle gets smaller. So changing r changes the radius of the circle. Let's move my circle around in space. And if you're really good at transformations, you'll kind of understand what we're doing here. This is all related to those graphing transformations that we studied in Math 111. So let's move my k coordinate. Now remember what k is. K should give me control over the y coordinate of the center point of the axis. So moving my k should do what to my circle? Move it up and down, yes? Let's see. Making k bigger. Hey, look at that. Making k bigger moves my circle up. What happens if I make k smaller? My circle goes down. So I can actually make my circle dance here. So as you can see, changing k moves my circle around in space. If you've been wondering why in the heck you would care about this, well, if you were going to use computers to move something around, this is kind of how you do it, right? Move this the center of the thing. What's h do? H moves my circle left to right. Yep, let's let h move on its own for a minute. So if I move my circle, my h coordinate, my circle changes. If I move both h and k together, I get a dancing circle. Right? All right, let me bring, and then, okay, so let's get a little crazy here and let's move my radius at the same time and I can get a bigger and smaller dancing circle. All right, sorry, I like Desmos. I'm playing now. Let me bring my circle back to center. Okay, so what do you need to know here? You need to be able to recognize and use the basic equation for a circle. R squared equals x minus h squared plus y minus k squared. You need to know what all of the different parts of that equation mean for a circle. So you need to know that r is the radius, k is the coordinate of the x-axis, k is the y coordinate of the circle, the center of the circle. H is the x coordinate of the center of the circle, and that r is the radius. All right, let's go back to my PowerPoint. Okay. So memorize. You are going to have to memorize some stuff in this class. Flashcards will be your friends. Okay. I will try to get some little Quizlet apps set up in the course that can help you also. So I'll try to build you some effectively some flashcards for you to use. So r squared equals x minus h squared plus y minus k squared. Let's play with this for a little bit. Let's write the equation for a circle that is centered at the point -3, 2 with radius 4. See if you can do this. Go ahead and pause the video here and make a stab. Take a stab at it based on your notes. All right, I'm going to go ahead and give you the answer. So here's what we do. We start with the equation of the circle. R squared equals x minus h squared plus y minus k squared. Fill in the holes. We know the radius is 4. Well, let me put my pen back into. There we go. We know the radius is 4, so we put 4 where r is. We know that h is -3, because h is the x coordinate of the center, so we put a -3 where h is. We know that k is 2, so we put 2 where k is. We simplify a little and we get 16, because that's 4 squared, equals x plus 3. Wait, my computer wants to restart and it can't do that right now. Okay, so we get 16 equals x plus 3 squared plus y minus 2 squared. Or sometimes you might want to go ahead and finish simplifying this out. So we would get 16 equals x squared plus 6x plus 9 plus y squared minus 4y plus 4. Collect our like terms and we get 16 equals x squared plus 6x minus 4y plus y squared plus 13. Usually we will just leave everything in the circle, but this is equally correct. It's just a little bit of work. You don't need to do that extra work. Just leave everything in the standard form for the equation of a circle. This class is going to be mostly about recognizing these forms. Well, actually, this class is going to be about a lot more than that, but that's okay. It's a fun class. I like these. So make sure you understand how to do this. Maybe look in the book and do a couple more examples that are in there. Again, try it yourself. Just reading this isn't going to make it work for you. All right, so let's try another one. I have a circle. We recognize a circle. The circle is centered at the point, well, that's kind of ugly. So that says x plus 1 squared plus y minus 2 squared equals 9. So where's the center of this circle? Let's go out to Desmos and take a look. Actually, yes. So Remember the standard form for the circle. My standard form is r squared equals x minus h squared plus y minus k squared. Compare that to the equation I have here, which is that 9 equals x plus 1 squared plus y minus 2 squared. Remember that the coordinates of the center are the points that are subtracted from x and y. So this x plus 1, that's really x minus negative 1 squared plus y minus 2 squared. So my circle should have radius of 3. So we should say r equals 3. And it is centered at the point negative 1, 2. Does that make sense? Negative 1, 2. Yeah, that kind of looks like the center of the circle. I'll take that. That's not absolutely necessary for solving this problem, but that's okay. It's good to know. So we now understand what we've got. We've got a circle centered at the point negative 1, 2 with radius 3. And we're being asked to find the y-intercepts. Okay, so what do we know about y-intercepts? Well, we should know, remind yourself of this if you don't know, that for every point, so the y-intercepts, we should know that the y-intercepts are the points where the curve that we care about, in this case the circle, intersects the y-axis. Now, the way that we find those is by setting x equal to 0, because at every point on the y-axis, the x-coordinate is 0. So we'll take this point, this equation here, set x equal to 0, and solve it. That will give us 2 solutions. Try this. Go ahead and try that on your own. Pause the video here. When you think you've got it, or when you're stuck, whichever one comes first, restart the video and go on to the next slide, which I'm going to show you now. Whoops. Where's my answer? Oh, the answer should be here. Okay, we'll work through this one together. I don't know where my answer went. Okay, so what do we get? Sorry, my screen's touchscreen, so I got to adjust it so I can write legibly. If x is 0, that means we're going to take this x plus 1 squared plus y minus 2 squared equals 9. We're going to make x be 0, so we get 0 plus 1 squared is just 1. Plus, now we're going to expand out the y minus 2 squared, so we get y squared minus 4y plus 2 equals 9. Combine our like terms. We get y squared minus 4y plus 3 equals 9. This is a quadratic, so we're going to bring everything to the left-hand side and set it so that it's equal to 0, so that we can use our quadratic formula. So we get y squared minus 4y minus 6 equals 0. A little quick mental check will tell you that that will not factor, so we're going to use the quadratic formula. So I'm going to put it up here, y squared minus 4y minus 6 equals 0. Let's erase my scribbling over here. Sorry for the illegibility. Writing with my fingers is my best skill. Try to start this. Now I'll try to start this next video. Okay, so I've got y squared minus 4y minus 6. You'll have to remember the quadratic formula if you haven't memorized it yet, or if you've forgotten it. Remind yourself what it looks like. Or you can use your TI. You can use your calculator. You've got your calculator. You can use your calculator to solve this quadratic formula or this quadratic equation. But for now, we're going to remember that y equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this case, b equals negative 4, so the negative of negative 4 is 4 plus or minus the square root of 4 squared is 16 minus 4 times 1 times negative 6 all over 2 times a is 1, which is 2. So 16 minus a negative 24 is 16 plus 24, which is 40. So what we've got here is 4 plus or minus the square root of 40 over 2. Now 40, you're going to have to remember how to simplify radicals. 40 is 4 times 10. So this is going to be 4 plus or minus 2 times the square root of 10 over 2. So what we have is this y coordinate is at the point 0, 2 plus the square root of 10, and this y-intercept is at the point 0, 2 minus the square root of 10. Make sure you know how to get from here to here and here. If you have any questions, please reach out. All right, so we found the y-intercepts. Let's take a look at another a little more complicated example. And this example is kind of silly, but it's kind of fun. And I'm hoping you can see how it could be related to more serious real-world applications. Let's skip this one, but I'll give you the answer. So go ahead and, so this is an example I forgot I had put in here. So we've got the line f of x equals 3 minus x, and that intersects the circle x squared plus y squared equals 16. But this video is getting a little long, so I'm not going to go through this one step by step. Instead, I'm going to just give you the answer here. All right. What we're looking for is the points where the circle crosses that line. These steps right here are that are on your screen now. Will tell you how to solve that. Again, make sure you know how to do this. Let's look at the ant. All right, so we've got an ant walking on a camping table where somebody spilled some pancake batter. Now the ant cannot breathe while it is walking through the batter, and the batter has a radius of 4 centimeters. For reference, that's a radius of just under 2 inches. So it's a fairly decent sized little spatter of batter. The ant's going to walk from a point 6 centimeters due north of the batter center to a point 5 centimeters due west. Someone's really bored on this camping trip. Now the ant cannot breathe while it's walking through the batter and is going to have to hold its breath. So we know that the ant moves at 0.8 centimeters per second. And how long is this poor little guy going to have to hold its breath? Let's see. In order to solve this type of problem, we have to introduce a coordinate system. And the easiest thing to do is put our origin at the center of the circle. So if we put our origin at the center of the circle of pancake batter, then we can write the equation for that circle. 16 equals x squared plus y squared. That is the equation of a circle that has radius r equals 4 and is centered at the origin. Now, I've already figured out the path of the ant is along the line y equals negative 6/5 x plus 6. How did I do that? Well, Remember, we were told that the ant was going to walk from a point that was 6 centimeters north of the center of the circle to a point that was 5 centimeters east. I hope it said east. Oh, west. Dang it. My point's in the wrong spot. All right. In the interest of time, I'm going to change my example here, because it really doesn't make any difference. This is no longer going to be west. This is going to be east. All right. One skill you really should have down at this point, solid, is writing the equation of a line through 2 points. If you are struggling with how I got this equation, please reach out to me and I will explain it to you, but I'm not going to take the time right now. So we got to do a few things. We have to find the points where the line crosses the circle. We do that just like that previous example. And then we calculate the distance between those 2 points and figure out how long it's going to take the ant to traverse that time or that distance. So here you go. Now, this is the whole thing all at once, and my line breaks are a little weird, but you can figure this out. Take it one step at a time. Start by finding the points where the line crosses the x-axis. If we do that, so there's a couple of different ways to do that. Let me talk about this for a minute. We've got 2 equations. Whoops. We've got 16 equals x squared plus y squared, and y equals negative 6/5 x plus 6. We only care about these points where we cross. Now, for the example I set up, of these we're in quadrant 1, right? So we only care about the positive x's and positive y's. If you were going to do the original example where everything was, where the second point was to the west, you would want to worry about only positive y's, but you'd need to worry about negative x's. But for this example, we're going to only worry about positive x's and positive y's. So what we're going to do is actually, I'm going to solve this equation for y. Solve the equation of my circle for y. I only care about the positive y's because I am in quadrant 1. So when I do that, then I get this guy right here. Now, we could say, well, that equals negative 6/5 x plus 6. And set that all and you know, do our algebra. It's going to get kind of ugly, but you can do that. What I did was I took out my TI calculator, and I apologize, I'm not at home, so I don't have one with me, but I will show you how to do this in a separate video if you don't know. Actually, if you don't know how to do this, contact me, and I will show you. If enough people contact me, then we'll set up I'll do a video. So what I did was I put this equation, this y equals 16 minus x squared, into my TI calculator. Any graphing calculator can do this. You do need a graphing calculator for this class. It is an absolute necessity. Then I put the equation of the ant, y equals, of the ant's path, y equals negative 6/5 x plus 6, into my calculator, and I told my calculator, give me the intercepts, the intersection points. Tell me where this line crosses this circle. And my calculator spit out a couple of points. Spit out the point 2.236, comma 3.317, and the point which would be this one right here. And the point 3.665, comma 1.602, which would be that one right there. Now we want to find the distance between those 2 points, so I apply the distance formula, and I get that ant is going to have to walk through that batter for a distance of 2.23 centimeters. All right. Okay, so far? work through it step by step. I promise it's not that bad. So now we need to figure out how long it's going to take the ant to walk through that 2.23 centimeters holding its breath. Recall that distance equals rate times time. So we can solve this to get time equals distance divided by rate. We know our distance is 2.23 centimeters. Our ant moves at 0.8 centimeters per second. We do that division and we get that it's going to take that ant 2.8 seconds to cross the pancake batter. So the answer is the ant will have to hold its breath for 2.8 seconds. All right, congratulations. You have reached the end of the first video lecture for Math 112. I look forward to working with you throughout this course, and I will see you again soon.